Still using extra memory to rotate a matrix? You only need 2 steps, no extra space. But want full solution? Check this video.
Hi everyone and welcome back. Today we will solve the leetcode problem, rotate image. We are given n by n 2D matrix representing an image and we need to rotate the image by 90 degrees clockwise. So a common approach here is to create a new matrix, then we use this new matrix to transpose the original matrix and then reverse the rows. Although this works perfectly, but it uses O of n squared extra space, which is not optimal. And keep in mind that here we have a constraint that we have to rotate the image in place, which means we have to modify the input matrix directly and don't allocate another 2D matrix to do the rotation. So the trick here is that we need to do everything in place, just in 2 steps. First, transpose the matrix, then reverse each row. If you still didn't get it, let's first define what transpose means. Transpose means convert rows into columns. So, for example, if we have this matrix, after transposing this matrix, it will look like each column will be a row, so it will be 1, 4, 7, and then 2, 5, 8, and finally it will be 3, 6, 9. This is how we transpose the original matrix. Then we need to reverse each row. So if we reverse it, the first row, it will, let's name this the transpose step, and this step the reverse step. So if we reverse it each row, it will be 7, 4, 1, and 8, 5, 2, and finally 9, 6, 3, which is equivalent to our output. And here, after doing these 2 steps, we will have our image rotated by 90 degrees in clockwise. So let's now move to the code. First, we will define a variable n that will equal the row size of the matrix. So will equal the matrix dot size, and then we will do the transpose step by iterating over the upper triangle of the matrix. Why? To avoid double swapping. So we will iterate over variable I from 0 to n, and for n j equal I plus 1, because we need to iterate over the upper triangle of the matrix, and j is less than n, and plus j. And the transpose is easy by swapping the matrix at I and j, and matrix of j on I. Okay. After this step, our original matrix in this example will looks like this one. And then we need to the reverse step. Again, we will iterate over each row this time. And we will call the reverse function in C++, and we will give it matrix I dot begin, the iterator, and matrix of I dot end. And this step will reverse each row, and we don't need to return anything because we do everything in place. So let's run it and submit it. And as you can see, it's 100% of the solution because in terms of time complexity here is O of n squared, which is optimal for this problem. And the space complexity, as we are doing everything in place, so that no extra memory is used, so space complexity is constant, is O of 1. And that's how we rotate matrix in place. If you want more optimized solution like this, please like and subscribe to the channel, and see you in next video. Bye.